1, 2, 1, 2. Everyone can hear me? Okay, great. Hi everyone, super excited to be here. My name is Ivan, and just 5 seconds ago, I was checking if microphone is configured properly, because this is talk about configuration management. I swear to God, if I don't get a award for the best segue, I don't know. Anyways, first of all, it's a bit about myself so that you would have an idea why you should listen to me in the first place. Okay. I've been at Bolt for a little bit over 5 years, and 4 out of these years I've been in a team which was platform and then turned into backend platform and then turned into a team with a funny acronym of PINT, which stands for Productivity and Internal Tools. And the mission of our team is to enable fast and quality implementation of company decisions. It sounds kind of vague and hand-wavy, but in practice it comes to developing and maintaining tooling for backend and front-end engineers so that they can do their day-to-day work more efficiently. And in order to do that, in order to support the whole engineering, we need quite a few people as well. So we have a team of almost 30 people. And we essentially have one manager, so flat structure, bunch of different projects, matrix dependencies, and so on. Pretty fascinating topic on its own. I'd be glad to talk about it. But today the talk is about configuration management. And if for some reason, if you're not planning to stick around until the end of the presentation, I got you covered, no worries. So what did we learn about configuration management? When we learned that the best configuration is no configuration. Amazing, great. But first of all, what is configuration management? So if you Google it, on Wikipedia, you will see some definition, some broad term, and honestly, it's a bit too complex for myself. I'm not sure I understand it very well. But for the sake of this presentation, configuration is basically config.js. So in any sort of application or service, you have some sort of configuration. So db config, some timeouts, and so on. If we had to put it into words, then it would be a set of values that impact your service or application in one way or another. And more often than not, you also have different values for different environments, and quite often also production contains credentials. So, 2 config files, right? Exciting. So what's so special about it? It's 2 config files, right? Well, the special thing about it is scale. Yes, scale. Let's go. But what do I mean by that? What are the challenges? And to understand that, I would like to invite you to the trip down the memory lane of configuration management at Bolt. So before Bolt was at the scale it is at right now, it used to be a small Estonian company, startup, a little bit over 10 years ago here in Tartu. It used to be called Mtaxo, and back then everything was one single Express.js application. And guess how its config used to look like? Yeah, exactly, it's 2 files. And there was only one person, our CTO back at the time, working on the app. And as the app grew, functionality grew, at some point we had to split, so it turned into a couple of services, and now each of the services had its own 2 configurations. And as you might have noticed, production configs also have credentials, so we had to do something about it. Probably not a great idea to store it in the same Git repository as the code. So what we did is that we took all of the production configs and put it in a Git repository. We put it in a separate Git repository that would have a more restricted access so that only a handful of people would have access to credentials, while everyone would have access to the code. And there were a couple more people working on the project now. As simple as the solution sounds, actually, this held up quite well. We were well in the tens of services, and this was still the solution that we used. But now imagine you have not 4 services, but 20 services, or 50. How about 100, 200, 1,000 services? Wow, that must mean there are at the very least 2,000 configurations. Wow, that is a lot of config, right? Scale, yes, scale, let's go. But wait a second. The thousands of services is not the only thing that we have at the company, right? We also have a couple of 100 engineers who work on services and maintain those configs. So if you calculate the number of configs per engineer, then it's really not that much, right? Well, guess which one is easier to scale? A couple of thousands of configs or a couple of hundreds of engineers? And it's certainly, most definitely, absolutely engineers. People are a problem. Let's just face it. I think you all have a smart friend, or maybe you are a smart friend, who told you that in any type of business, the most complicated problems are always people issues. And this is kind of the case here. And we will see exactly later how it plays out. But for now, let's focus on the solution that we started with and see if we could improve something. Well, yeah, you probably have a question like, why do we store credentials in a Git repository? Sounds a bit questionable. Probably the biggest thing you think first away is security. So credentials are plain text, they're not encrypted. But there is one more fundamental issue at play, and the issue is, you guessed it, it's people. So the issue is if you have a large enough engineering organization, then you have all of these people who want to work on their services. They constantly update their production configs. They work a lot with credentials. And you only have those couple of people who have access to the repository with production configs and these credentials. So they bug them all the time. And those couple of people are getting really tired of updating everyone's configs to the point where it does not scale anymore. So this is clearly a bottleneck. Well, what could we do here? Let's, I don't know, add more people. OK, cool. So now the throughput is a bit better, but another thing happens. Now the amount of people who have access to the credentials comprises a formidable chunk of the whole engineering organization. And, well, that can be great. Why exactly? Well, it's because of Git. So finally, we run into issues with Git. And in Git, you either have access to everything, or you have access to nothing at all. It's one of those two. So with Git, it looks like this. You have access, if you only need access to credentials of your service, you get access to literally everything. And let's remember that service also needs a way to fetch credentials somehow. So the same thing happens in service. So that's obviously not great. And instead, we would like to achieve something like this. So every developer only has access to the secrets that are relevant to their services. And from service side, service also only has access to credentials which are relevant to that service. And in this way, we would have scoping both on the developer and on service level. So long story short, we considered different solutions. We were looking for options. And surprisingly, AWS S3, yeah, you heard it right, S3, had all of the features that we needed. And the most important feature was scoping, exactly. So this is how the solution looks like. Now every credential becomes its own separate file. And in S3, you can organize those credentials by service. And you can group service under service groups. And then later, you can use S3's access control list to give access to particular people to specific subpaths. So it would look something like this. The most common use case would be that the team owns a bunch of services, and usually those services are conveniently grouped under the same service group. And so engineering manager and tech lead would have access to the credentials. And so this would translate into a simple ACL to S3. And then also you can have more specific scenarios like developer needing access to some specific service or maybe even to a credential. And on service side, you can see that now also it's pretty trivial now that all the credentials are organized by the service. We can also easily scope access for service to credentials. And that is basically it. That's the whole solution. That's the beauty of it. Now, we started with an issue with people. Did we solve it? Well, yeah, kind of. Because we started with the issue for the whole big engineering organization. And now we split it into issues. Basically, we split it into different issues for different teams. So now it looks something like this. You have a bunch of teams, and then TL or EM or both have access to the credentials relevant to that team. And on a team level, 2 people can easily manage access for the whole team. So people issue is done. But wait, this is engineering conference. You're supposed to show some code. How does it work? You said S3, but there needs to be some front and backend. OK, let's go. So here's an example of excerpt of production configuration. And you can see here that instead of putting the secrets in the code, the credentials, we put the special placeholder. So secret.strings is a placeholder that will, in runtime, resolve to the actual value, to the actual credential. And since we write the code in TypeScript, there's also compile time checks. So you can see there is secret.strings for an array of strings, secret.string for one string, and so on. And also there's additional runtime checks to make sure that when you're reading the value, it actually matches the type. So everything's super safe. And once you define placeholder in the code, you also need to put the value somewhere. And for that, we have built lightweight frontend on top of S3. And for the last example, for the subscription key, it would look something like this. So this would be the UI. It is called Secrets Portal, super secretish. And then if you look at the path there at the top, you will see that you will see that it contains the name of a property itself. Microsoft places XRX subscription key. Then if you go a bit back, then geo is the name of a service. And before that, geo is the name of the service groups that geo belongs to. And you have schema string, pretty self-explicable. And yeah, that's basically the secret solution. So we used to have a Git repository, kind of a bad smell, and now we just have secrets. And also, if you've been paying attention, one really cool thing happened is that we don't really have actual credentials in production config anymore, which means we can take our production configs and put them back into the repository, which is arguably much more convenient to have them there. So amazing, yes, success. We solved credentials. Did we solve all of the configuration management? Well, yeah, bad news, not quite close. So let's go back to this slide. Remember how I said that people are an issue? Yeah, a bit of an overreaction maybe. People themselves are not the issue. I mean, you're all great, amazing audience. But we hire more people because more people can get more work done in a shorter amount of time, and we can build cool stuff, go to the moon, et cetera, et cetera. But the problem when you're scaling an engineering organization is communication. And communication is inherently expensive. It's inherently a complicated task for humans. And so let's look at the communication from the perspective of configuration management. So at the middle of all of it is developer, right? And you would think that normally developer just goes, writes their service code, and puts the config, and they're done, right? But in reality, they actually happen to talk to quite a few parties. So one of those parties is SRE. If you have any type of resource configuration like a DB config, you also need to make sure that there is actual database behind all of this. So you go to SRE, open a ticket, and wait until it's done. Developers have to come to talk to us, Pint, reminder of the funny acronym of our team. And in Pint, we develop libraries, the framework that all of the developers use. And those libraries also have do have some configuration. If developers don't know which values to put or they want to change something, they come to talk to us. Then developers obviously talk to each other. Inside of the team, outside of the team, sometimes you need to go to some other team to tweak things, and sometimes you might need to update their config as well. And finally, developers talk to operations. So in Bolt, we operate in many cities and many countries, and there are a lot of pieces of configuration which are specific to specific geographical areas. For example, here in Tartu, there are a specific price per kilometer and per minute. And so this is one example of the city-specific configuration. And we have a lot of those configs. But the operations are the people who actually have the domain knowledge, who know which values should get there. But if they want to put those values in code, they have to talk to developers, and developers have to do it, unless they have some tooling. So yeah, looks like developers actually have to communicate a lot, and we identified that communication is an issue. So this is like an alarming amount of communication developers have to do. Hot take. What if we didn't have any configuration at all? Then we wouldn't need to talk to anyone, right? Which is why the best configuration is no configuration. I mean, as naive and simple as this idea sounds, this is kind of where we started. So we started going everywhere and seeing, can we kill any type of boilerplate? And yeah, so we started killing configuration. And to bring you a couple of examples, one of the things we did, we added a bunch of default config values to the libraries so that developers wouldn't really have to think much. When using the libraries, they wouldn't have to come us and ask the questions, and every library can be used with reasonable defaults. But of course, you can configure it however you want. Another example is that we got rid of local ports. This is one piece of annoying static configuration that developers had to do. So if you want to run multiple services locally, we don't really Dockerize them. So they have to have different ports, and once you go like past, I don't know, 50, 100 services, you can imagine this becoming quite a headache to manage. So we sat together, thought real hard, and came up with a solution to automate all of that, and developers don't have to provide those ports anymore. Okay, cool. But so far these seem like kind of random updates, right? What if we took a bit more structured approach to improving configuration? And let's go back to our communication diagram, let's call it that. What if we tried to split the config and split it by the party that developers have to talk to? Okay, so let's do that. Remove some arrows, move them to the side, boom, done. So for SRE, we have infra-level config, which is a config related to any type of resources. For Pint, we have library-level config. For developers, we have service-level config. which is pretty much anything that developers put in production configuration. And finally, for operations, we have business level config, and this is mostly the city and country config that I mentioned previously. And we call this kind of mental model 4 levels of configuration. And now if we take a look back at the optimizations that I just showed, they neatly fall into this category of library level config. And this is most understandable because we aspire to know our products best, so this is where we started. But we still have 3 more levels to go. So let's go. First is infra-level config. Infra-level config is about managing resources. And to understand it better, we first need to look into developer flow. So let's start with the database. So in Bolt, I guess it's not really surprising or a secret that most of our services are stateful. And since we're following good microservices patterns, it means that every service has its own databases. So from those 2 statements, most of the services use the database, have their own database, therefore they have database config, and this config looks something like this. So as you can see, it is really strikingly similar. So the only thing that is different is the database name. Well, not the only thing. If you think about it, the username and password are just placeholders, so they do actually resolve to different credentials. But still, they're so similar. Like, could we do something about it? So first, let's think how developers interact with it. So as a developer, you go and write service code. Let's say you're creating a new service, and you need a new database for it. And then, once you're done, you go and need to make sure that the database is created, so you go and create a ticket for SRE. SRE comes, picks up the ticket, provisions the resource, which is database in our case, and also sometimes you do have credentials. So if there are credentials, SRE also needs to go and put credentials into secrets under the correct path, hopefully, so that later the service can pick it up and resolve it. And finally, once all is done, SRE goes back, marks the ticket is done. So developer sees that the ticket is done and they can go deploy their service. So this is exactly what they do. And finally, the service in startup goes to secrets and hopefully fetches the credentials that are previously put by SRE under the proper path. So if we zoom out of all of this, it looks like this. OK. Well, not exactly OK. As you can see, there are quite a few actions that are done by people. But most importantly, there is this connection between developer and SRE. They have to interact in form of a ticket. So how could we improve here? Well, we can see that SRE are kind of do a lot of things. So could we automate it somehow? Yeah, sure. Boom, done. I mean, easier to do it on a diagram. But if in reality you do have a good structure, if your resource management is standardized, then it is doable. But it still takes a great amount of effort to do it. Oh, wait a second, by the way. How is automation supposed to pick up a ticket? I mean, we do have LLMs, all of this good stuff these days, but this sounds unnecessarily complicated. Automation can pick up any type of structured data. So let's replace our ticket with a JSON, and let's call it JSON claim. And JSON claim will be a file that has all of the information which is needed in order to provision the resource. So in case of the database, you only need 2 things. You need the service name, and you need the database name. And based on the service name, you can generate the username, and the password is generated on the fly. So a simple JSON with 2 fields will actually suffice for the automation. OK, we automated the SRE. SRE can go do cool stuff. So what do we have left? Well, we have a developer doing 3 things. And arguably, writing code and deploying services is actually what we're paying people to do. So at least for now. Hopefully, we're not all out of jobs anytime soon. But there's still this part with creating the JSON claim. And this sounds kind of annoying, right? Like, I mean, what if you could not create it? What if somehow you just go and write your service code and something understands that, oh, yeah, you're using new database here, and just boom, this file appears on its own? Would that be too much to ask for? Well, obviously not. We do this at Bolt, and we use in order to do this, we use the generator. So the generator is an internal piece of tooling. It uses static type analysis to analyze our service code, our service definitions. And based on that, it is able to identify patterns and extract some data about our services. And then it takes this data and uses it to generate a bunch of helpful files. So as an example, this is one of the service definitions. And as you can see here, we are initializing a database. So generator, what it can do, it can use the TypeScript compiler API to parse it gets the AST of the program, and then goes just statement by statement and is checking, like, is it the DB pool? And then it goes to this statement and sees, like, oh, okay, wow, you're initializing a DB pool. Oh, you even provided a database name. It's right here. It's Taxify event. Yeah, legacy naming, I know. So now suddenly the generator knows that you have a service which is using a database, and you have a name of the database, and obviously you also have a service name for the service, because generator knows what it's parsing. And if you remember, those are only two things that I needed for the JSON claim. So now, yeah, generator parses the service code, finds the good stuff, and then based on that, generates the JSON claim. Now you write code, and the claim generation happens on its own. Magic. So if we zoom out once again, as a developer, you write your service code, you deploy it, and you don't really have to think about configuration. In fact, you might not even be aware that there's some magical claim configuration generation stuff happening in the background. And in Bolt, we're super proud of this solution, and we call it configless. Why configless? Well, because there's no config, kinda. And the cool thing about configless is that it's not really specific for database. So you can actually plug any resource here and repeat the same steps, and you're going to get the same outcome. In order to explain the next thing, I'm going to need help from my manager. So everyone, welcome. This is Evgeny, head of Pint. This is just his Slack profile picture. He looks the same on an average day. And Evgeny loves plant.yml. Does any one of you know plant.yml? Wow, amazing. Amazing technology. But basically, it's a declarative language which you can use to generate diagrams, so kind of like a mermaid. I guess mermaid is much more popular these days. And Evgeny loves plant.yml like a lot. And he has generated a lot of diagrams, but right now we're going to need this one. So configless is basically our own implementation of a concept that is called, or that maybe we called, claim automation. And here on the left, you can see that you can plug any type of resource. So we looked at MySQL, but we also have it implemented for SNS SQS. Right now, we're kicking it off for Redis, and then we have some more resources in the backlog to implement it for. And so you write service code, you start using the resource, and then there is a step of claim generation, which is where our generator kicks in. So generator generates the claim. After that, there's a step of claim publishing. So once you publish the pull request, the GitHub action is able to pick up the newly generated claim. After that, there's a step of claim provisioning, which is taken care of by the automation. Automation takes the generated claim and does the automation, provisions the resource. And finally, there's a step of claim verification, which we technically don't have implemented. But the idea would be for your deployment orchestration tool to look at the pull request, look at the change set, and see if there are any claims associated with it. And if there are, for each of those claims, it would go and check if the associated resources are provisioned. And if any of them is not provisioned, then it doesn't even make sense to deploy the service. But as I said, we don't really have it. But if you forget to provision one of the resources, then the service is just going to scream really loudly at you at startup. So this is fine. Also famous last words. But anyways, this is configless. And if we go back to our 4 levels of configuration, configless kind of solves infra-level config. Like any type of resource that you have, this is just a formula. You sit down and do configless for it. Of course, easier said than done again. For every type of resource, it takes a lot of effort. You do have to have a high level of standardization of everything. For example, with S3, we're currently struggling because we didn't really enforce like environment prefixes from the very beginning. And now there's a bunch of stuff in S3, and like if you think about migrating it, it's kind of, how do you even approach it? I don't have an answer right now. So yeah, but if you start using a new type of resource, then early on, it pays off to think about this type of thing. This is why it's good to do things one specific way. OK, so we still have two more levels to go, and really quickly about them. So for service level config, developers obviously wanted a way to update the config dynamically in runtime, because by default, all of the config is static. If you want to update the config, you make a pull request, you have to deploy a service. If you have something that is really volatile, changes all the time, that's obviously a headache. So developers have been asking for it, we implemented, we called it dynamic config, no surprise. Dynamic config is kind of architecturally pretty similar to secrets, because it is also based on S3. You also put a placeholder in the code for the place where you want dynamic config value to end up. And also, if you want to modify it in the runtime, you go to a user interface, and you also do it there. So kind of like secrets, but not secrets, dynamic config. And finally, for business level config, we do have another solution, which is called remote config. This is for managing city country level configuration. And remote config is heavily relying on the generator, because it really does a lot of heavy lifting and magic here. So from developer's perspective, what you do is you define a TypeScript interface, and then you reference it in your service definition. And then the generator from there just completely takes over and generates everything else. What I mean by everything else is that it takes and generates all create, read, update, delete API for that config, just actual API that you can attach to your service. And more importantly, it does generate the user interface for editing this config. So from developer point of view, you need to go to define an interface once, and then all of your operations can go and use the UI after that. And they do have permission scoping as well. So if you only have access to 2 cities, then you can only modify config of those 2 cities by default. So yeah, as you can see, a lot of heavy lifting done by the generator in this case. So yeah, those has been 4 levels of configuration. So what have we actually learned from all of that? Well, the first thing we learned is that simplicity is key. And while that may sound like inspirational Jason Statham quote, it is kind of true. Simplicity is key. One good example is secrets. So in secrets, we did it once, and we didn't really have to touch it much since then. I think, if you can show the solution on one slide and there are like 5 elements, it can also be considered pretty simple. And one more cool thing about it is that after we did it, data platform came to us and said, oh, hey, you have this cool secret stuff, but it's only for your backend TypeScript services. We also have our own code in Python. We would like to use your credentials as well. And we did nothing. But what I mean is that a data platform went and implemented their own client in Python, and they could completely reutilize existing architecture and things in place, and it just worked. So we didn't even have to do anything. So simplicity is key, and from my experience, it is a very good idea to put it as a non-functional requirement in quite a few things. The next thing is that the generator is king. If you are not impressed by configless and remote config examples, then at the very least, you can channel your laziness, because generator writes code for you, and you don't have to write it. And I think that's always great. So we do have quite a few use cases for the generator. At the very least, we use it to generate our internal API clients, so you can easily use some generated code to call other service. We generate a lot of stuff for our testing setup, so like a bunch of mocks. For example, if service is using a database, we generate database mocks automatically and so on. Otherwise, you would have to write all that by hand. And we've pushed this concept quite far, and Configless is one great application of that. So we are seeing real promise of that, and in the generator, and we keep using it for more use cases. And the final word of caution is that misconfiguration at scale is really costly. So if you ever have to change a value in one value in all of the services, then you can imagine that how many things can go wrong. And unfortunately, we do have some experience with that. But even if you change the configuration incorrectly in one service, then if it's the service somewhere in a critical path for a business, then it still can have massive consequences. For remote config, for example, this is not as critical, because remote config is always scoped to a city or a country. So if you mess up, it's only on that geographical scale, which is also not great. But for dynamic config, if you update the value in a service, it's updated everywhere because service is deployed everywhere. Which is why for dynamic configuration, we also had to implement 4i review system. So two people, your teammates or your manager, have to approve the change before you apply it. But the most important learning was that the best configuration is no configuration. Thank you.
Wow, this is super awesome. As I understood, actually you're trying to get rid of communication in Bolt.
Trying to get rid of communication.
Interactions between people.
Yeah. People are overrated.
Okay, cool. But what would you say? What is like? I'm not sure it's exactly like a simple solution, but what is the scale at which this kind of generator actually, becomes useful or becomes feasible to build? Or is there some open source or some available tools already for this?
Yeah, I think there is, when we analyze the functionality that the generator provides, some of it can be covered by some other tools, like the API definitions can be covered by a bunch of API contract-based stuff. But for some of the things, like we do tend to build stuff in-house, and in that context, it does help quite a bit because we always know that whenever we use some new functionality, we can always do the generator magic around that. So yeah, for me, it's kind of hard to say at which scale it becomes useful. I mean,
if you had 10 microservices, would you have the generator?
10 maybe not. Like 50, I would start thinking about.
But would you put your secrets to the config files with 10?
This is how it used to be.
Cool. Yeah. Any other questions from the audience? I'm sure there is. Yes.
Hey, so in case of generator, I assume that it works with every service. And if a person working on generator makes a mistake, it would affect every service. How do you make sure that that's not happening?
Just really good testing. Yeah, it's kind of sucks that you asked this question because literally a couple of days ago this exact thing happened. But it was a mistake in the process, I would say, because like you do have like a lot of changes all the time. You change like one line in the generator and you regenerate the stuff for like over 1,000 services. And the important thing is to test it. So if even one service would be deployed with this change, this would have been caught. But unfortunately, this didn't happen. So yeah, like one thing is important to understand whether your changes in code, whether they have any type of runtime consequences. If they don't, they can be usually safely applied. But then again, like you need to be really careful in estimating, does it have or does it not? If it does, you should always deploy at least one service with those changes.
More questions? Raise your hand, you get the mic. Oh, there is one.
With configureless, how do you avoid kind of situation when developer commits some weird config to his own repository and you pick it up and you spin up 200 databases or something?
I think, yeah, good question. I think we just don't allow this type of stuff in general because you don't put a config for a list of databases. It's just picked up automatically based on your code. And in your code, like if you would instantiate 200 databases, I mean, someone would notice, or at the very least, we do, like the generator not only generates the code, but it also does some static analysis checks, basically. So we do have quite a few opinionated ways of doing things, and like checking that one database is used in a service is one of them.
Okay, thank you.
We have time for more questions. I think there are opportunities. Just raise your hands. One in the front row here.
So my question is, how many developers are needed for to make those developers who are like creating new services or writing the or creating value for a customer? How many developers you need to make one developer to work? I mean, how is the ratio for the developers who are making internal tools compared to developers who are creating new services or value for clients?
Yeah. Pint is not the only team that supports engineering. We have also SRE, data platform, database team, and I didn't forget anyone, yes. And this is group the foundation, and foundation I think has a cap of 15% of the whole engineering, something like this. It does feel a bit limiting. It's quite challenging to keep up with everything, which is why we put a lot of work into prioritizing things. But yeah, it's like we do have considerably more engineers than people who support the tooling for them. And somehow we float.
Yeah.
Cool. Let's take one more question. Here.
So is the database provisioning service open source? Can we use it?
No.
Why not?
Why not?
Seems like a good tech. Why wouldn't we use it?
Yeah, cool stuff. Because it is quite specific for the structure that we have in Bolt. So we do have, for example, we have MySQL and TiDB, two different engines, but we also have a pretty specific way of sharding the databases. Like, I guess the question could be generalized to why don't we open source like anything? That is a good question. I don't think I have a good answer for it, but at the very least, like in the current state, it's just like very specific to the way the shards and clusters and everything are managed at Bolt, because even internally we don't really have super good high-level abstractions for that. So it is kind of coupled quite a bit to how we do things. Sorry. I guess what I meant to say is sorry.
Okay, another round of applause. That was a nice story. Also, go and find Ivan anywhere around this building, and then you can ask more questions.